Okay, today we are going to continue exploring Mastra AI. So if you remember last time we looked at Mastra and what it's capable of doing. We looked at what it has a lot of capabilities, and you will see that there is a lot in it. There is starting from models, um, then agents, then RAG, then workflows, then memory, then tools, of course, and then of course structured output. But I think one of the most you know, for me, the interesting things that Mastra does for us is streaming. Streaming is pretty difficult to do because of the shape of data that you're trying to stream. You have data coming. If it was just a stream of plain text, right? Like Markdown and so on, that is easy to handle. What comes in, you send it straight to the output. But you can see and you know that the data that comes from an agentic back end is not always just text. Sometimes, in fact, most times it's structured. From a normal LLM, it can give you text, but from an agentic backend, it's going to give you structured text in a JSON format, right? That has things in it. It has messages, it has tool calls, it has reasoning, it has a whole bunch of stuff, right, embedded in it. As a matter of fact, right, if I were to take um, maybe just a typical endpoint, the structure that comes from it, which we'll see shortly, right? You find that it is not just plain text. So because it's not just plain text, you can't just stream it as it comes in, right? The data has to be a chunk that makes sense. In other words, if I were to chop off a piece of JSON and it's incomplete, um I cannot decode that JSON and extract anything meaningful from it. So I actually have to wait for that JSON to be complete. So I think one of the things that streaming has been able to do is split it in chunks, right? So the chunks come as chunks of JSON, what we now call there's a standard called ND JSON, which is new line delimited JSON. So it's basically standard JSON, but it is broken up into small chunks separated by new lines. And then each of the chunks is a valid JSON, um, you know, string that can be properly decoded so that it doesn't cause errors. So being able to assemble all of that and then pull out the actual content from it, those are some of the challenges with streaming. So Mastra helps to handle a lot of those kinds of challenges. We're going to look a bit more at the streaming, what to do with Mastra streaming. Then of course, Mastra has a tooling system as well, similar to LangChain's tool, and even all the built-in tool approaches that all of the um, LLM AI providers have, their SDKs have. Okay. So, and then Mastra is provider agnostic, right? We already saw where you could actually just pull in the providers and their names. And once you pull a provider's name, you can also get the available models. So the other beautiful thing with Mastra is that it is in TypeScript, so there's type hinting, there's code completion that really helps with your coding. So you don't have to have a lot of difficulty trying to remember whether what you're doing was the correct thing or not. And that's really what makes it great. Then we have yeah, so basically Mastra gives you all of these you know, uh, structured primitives that allows you to build a reliable agentic application, right? So for Mastra, we have moved from the point where we're just talking about LLMs, to where the basic primitive is the agent itself. So Mastra starts with agents. Even though, yes, Mastra has models that allows you to access, to route model routing basically that allows you to route and select any models that you like, right? But you can see that it starts with this basic agent um, primitive, basically. The agent is the basic concept. The models feed the agents, yes. But the agent is the basic concept. And then you have workflows. So workflows are similar to LangChain's chains, right? But it's more flexible than the chains because LangChain has chains and then it has the agentic React loop, right? The agentic loops basically. But with Mastra's workflow, Mastra orchestrates it. So with Mastra, you can do chains, you can do the loops as well. And the reasoning loops are part of it. And then of course the tools. So you can build functions. With Mastra, it's very easy for you to build a tool. You declare a tool and you pass in the callable, the tool itself, the tool function as a callable. Um, then memory, we're going to do a bit with that as well. Streaming, which we just talked about, observability. So we're going to look at some of those. Right. So we've talked about all of these abstractions and how to implement them. Um, for Mastra, it's very easy to create an agent. You just use a new agent, you use this new agent um, syntax and you create an agent, right? So it's easy. You can add other things. The basic thing is the name, the instruction, which is basically a system prompt, and then the model itself. Okay. So makes it easy for you to pull that together. Then you can add tools. So to add tools to an agent, you create a tool, right? And you pass that tool along to the agent. We'll also see how we can do that. So you create a tool, then you pass a tool along to the agent. So this is how you create a tool. You import a tool constructor basically from Mastra core. And then you use that, you specify the name, the ID name, right? Description, then execute, which is the thing that you will use to basically run the tool. Okay. Then you have um, yeah, when you create an agent, you pass a tool in along as a list. So then we have workflows. So you create workflows in order for you to orchestrate the agents. And you can actually have the run method here where you can decide how you do your orchestration. And you can see here, you fetch content and then the summarizer, an agent you already had, which you had created in your workflow and added to your workflow. You can then pull that. So um, the workflow allows you can add agents to workflow, right? And when you add agents to workflow, it means that basically you can call any of the agents in the workflow to do stuff. So the workflow allows you to manage that orchestration. Then we talked about streaming, and streaming is really easy. Um, well, easier than you would have if you had to do it yourself. Okay. We had a bit of challenge streaming last week or last Wednesday, because we were kind of using an old API and you know, we're using an old API, but the library that we pulled in for our demo was the most recent one. So we had a bit of challenge. And I basically had to go check documentation to see their most recent. So I think that's the same kind of challenge we had with LangChain. That just shows you the fact that these libraries are really evolving very fast. Okay, we talked about MCP as well. So Mastra allows you to connect to MCP, right? So you can also make your own MCP server, or you can connect to existing MCP servers and pull in information, from existing tooling. All right. Then we talked about memory as well, even though we've not done a demo, but um, when you create memory, then you can associate memory to an agent. So once you give an agent memory, then the agent is able to do stuff. So we are going to do all of this in our samples. Then the RAG, for RAG, it's you create an instance of vector store, and then you can basically just use agent.generate to generate content, and then you can pull the context from the vector store and pass it in. So you can either pass this as a system prompt, or in this case, you pass it along with the messages. And then workspaces. So we talked about workspaces that allow you to scope and organize your agents. So agents that are in a workspace, is only the agents that are in a workspace that can have access to each other and to the other things in the workspace, including workflows and so on. So yeah, when you create a workspace, you can add agents into that workspace, right? And you can add any bunch of other things as well. So that is very key. Then you can also create Mastra server, right? When you create a server, you can also add a workspaces, and you can also add agents into the server as well. So observability, doing evals, and so on. Yeah, so recently, Mastra started including voice capabilities. So we talked about speech synthesis, text to speech, speech to text. So with this, it becomes even easier for you to implement conversational speech and voice agents, and applications. And then we looked at deployment. They also make it easy to deploy, right? By adding deployment targets. So deployment targets make it easy for essentially the whole um configuration, scripting, automation that is needed for deployment is all contained in their deployment in the deployment part of Mastra. So they have pre-built deployment configurations which you can just key into it, right? Actually need to um you don't actually need to write any yourself, right? You basically can just access all of those directly. So um makes things very easy. It's very, very easy, right? Very, very easy. Okay. So we did a bit of this, right? Just to set up a Next.js project. So typically what you do in Mastra in the Next.js project is you will have a folder structure, the typical Next.js folder structure, app slash, and then everything for your front end, you put in the app folder. Then next to the app folder, you have a Mastra folder where you normally will arrange it this way. You have Mastra, then you have agents, tools, workflows, and a bunch of, other files. So of course we had already started a hands-on. So I had already done a kind of demo mini project, which we will now take a look at, a guided mini project um, that we will use to demo Mastra. So let me switch to that. And so it's going to be a summarizer agent. But before we go to actually doing the summarizer agent, which I had already started, I will first demo each of the individual elements of Mastra. Still using the same project anyway, but so that we can understand. Okay. So yes, we started off with this, right? But I'm going to start by just taking us through the things that we will need to learn. So let's start with basic stuff, right? The first thing we want to start with is the let's start with agents, right? Um, so I have a full tutorial here which we will we will use. Okay, right. So yeah, we're already getting this. We started off I actually dumped something here, but API call error, user not found, um, response header, access control. So I'm having a permission issue. I think my um, key, well, this looks like it's a recent key. So I need to check. Maybe I'll go get a new key um, from Open Router. Oh, I use PNPM. Okay. Um, Give me a second. Okay, I need to have access to the repo so I can make changes. So I'm giving myself access. Okay. All right. So, um, Okay, so let's start first of all. Yeah, we have a .env. I need to check my open router. So one way I can quickly check my open router is I already have the code here, and I have my postman, which I'm also going to share my postman so you can see what's going on there. Um, okay, so I'm sure you'll be able to see my postman as well. And I have already tried to run a few things. I got the error, user not found. So what this means is that my open router keys probably expired. So let me just get a new open router key. So while that's going on, the first thing that we want to try out is let's go there so we can see. The first thing we want to try out is simple creating an agent. Okay. And then just a simple agent without um, you know, doing anything with it. Just a simple agent, which is basically just a model. Okay. Okay, need access. Okay, so here we are. So the first thing is let's create a simple agent, right? Based on this. So let's just start there. So I know I've done it already. I've already done it, but um in this case we will just run it, you know, like um let me test it. So you can let's create this. So it's simple agent and then we can invoke this agent. So first of all, you create the agent. To create the agent, you import. Okay. Import agent from Mastra core. So we import agent from Mastra core. We had already installed the dependencies. Then it becomes very easy to just create the agent. So summarizer agent. Um, That's not the correct. Oh yeah, this key is not the correct key. So I need to find where I have the correct key. All right, so this is okay. So we have a key now. Um, all right. So we'll go through each of the um steps. Just start with first one, which is creating a basic agent. Okay, so again, this could be anything, but we'll just do this basic summarizer agent. So we will import and we will use. Okay, and so I'm not using OpenAI. I'm using Open Router and we'll use NVIDIA Nemotron. Let me just get this. There's actually auto complete, but I guess it hasn't booted up yet on this, right? There should be autocomplete. Okay, hold on. This should be Mastra core agent, right? That's where you get agent from. And there should be ID. Yeah. So it's still the same problem of I'm using old code, but yeah, summarizer. And the name will be the name we actually want to see, which is summarizer. Okay. Then this will now give me the autocomplete NVIDIA. So it's interesting. Let's wait for a bit and see the autocomplete coming in. Right. So this is one of the good, this is one of the benefits of using Mastra. So it gives you autocomplete, which is really, really helpful. I don't need to try to remember everything. Okay, so that's the agent. And we can then let's say I want to do just a little bit of let's say I have a testing script. So I'm going to add a testing script outside of Mastra, right? Just outside of Mastra, maybe here. I'll create a testing script which I'll use for testing index.ts. Okay, and I hope that my version of TypeScript is so import sorry, my version of Node here will be able to run the TypeScript. So I'm going to import um this agent, right, from Mastra agent summarizer. So I'm going to import summarizer agent. I'm going to import summarizer agent from Mastra. We could just do Mastra should be at then Mastra agents summarizer. Okay. Then so summarizer agent is an instance of an agent I've created. So I can just use it directly and say summarizer agent dot so how you call an agent is to use we can either call stream if you want to stream, right? So since they have built-in streaming, you can just call stream. And then you pass in the messages, which is a message list input. So the messages would be basically a list, right? Message list input is a list of messages. And each of these is basically messages that follow the Open AI standard, which will be role and user, right? And then content is, um, um, what is your name? So this is typically how you would do it. Of course, this is you have to because it is stream, you have to await, okay? You have to await, right? And you can then go through to read the stream, you can go through um you can go through chunks, basically loop through this stream and you just um await again const chunk of stream. So this is a very easy way to read through the stream, right? And then standard output. I don't know if this is what I would do, but let's just say console.log, right? And then chunk. Okay. Though what Mastra returns back from it is so it's not an iterator, but you can get an iterator from it, from something like maybe get from text. You can say text stream, right? Text stream will now give you an iterator, which is a readable stream. So it's only going to give you just a text content. You can try different things. So with this, we can try a little and just say node index.ts. So, okay, so probably I need to specify the packages properly. Um, let me just use a relative import, right? A relative import. Okay. Cannot find module workspaces, Mastra UI, Mastra agent summarizer. Mm, Mastra agent summarizer. Well, I don't know if adding .ts will help. So let's see if that helps. By the way, I think I need to stop this because I'm not even doing anything with the yeah, I don't need to run it that way yet. It's just taking up a lot of. So now it's telling me I have a problem. So um okay, so the problem I have is that my version of Node 24 should be able to read package.json. So let me add a type here. Type module to minimize these errors. But yeah, but that still doesn't solve this error. So I need to fix this error. Of course, I need to load .env. So let's set that up from, well, Next.js would normally have done that for me, but import config from, but I already have .env installed anyway. Not directly, but as a requirement. So, and then I'll just run config here and should be able to pick up that, right? Okay, so you can see how interesting this is. Okay. Mastra actually takes this and it streams it, right? Now, because I'm using console log, that's why it's dumping each one on a separate line, right? So you can see I'm getting chunks. I'm getting chunks. That's the value of the streaming. Now I could actually use instead of doing a console log, I could do process dot standard out dot write. Okay. The benefit of this is that this does not write it, you know, per line. It just continues writing on the output. So it's now going to give you a streaming behavior, right? So that's the benefit of using process the standard out dot write. It's going to give you a streaming behavior. So if I now run this, you now see my output coming out in a stream. See? Um, yeah, one thing that is nice to do to avoid this thing that has just happened here, where the prompt for the command line, prompt kind of ends on the same line as this. I have to write a new line at the end. So I can write a new line now, which is slash n. Okay. And so let's try again. You could see that behavior where it was kind of, chunking it and streaming it, right? So it says name, Nemotron, created by NVIDIA, role, expert summarizer, concise structure summaries. Now, why is it telling you role is expert summarizer? It's because in the agent itself, if you check where the agent was created, we gave it the instructions here, which is kind of a system prompt. So that's how you create an agent. Very simple, right? Okay, now let's move to the next thing, which is um, after I have done the agent, right? The next thing I'll want to do is tool calls. So for us to do tool calls, I'm going to create a new folder and put in my tool calls here. So I can have tools slash, um, yeah, so the tools, each tool, well, let's just call them tools.ts. So we have tools, but then you could have a whole number of tools here. One of the things that I think I would like to do is a tool that kind of um, does RAG, but we'll get to that soon. So to do tools, you import tool from again Mastra core tools. So that's where you import tool. Then after importing it, we can then use the tool. So this is how you use tools. Okay. You have to pass in I suppose you have to pass in IDs as well. Um so again, because this is TypeScript, we can Yeah, again, we have a change in the interface here. So tool is a class. Okay. So when you create a class, um, okay, so the the easier um function to use is create tool. So let's use that. Then we'll also import Z, which is Zod's we can use Zod's I will need to install Zod as well. So I was using npm install Zod. Yeah. So while that is going on. Um so yeah, so to create tool, use create tool. Now I already have some create tool that does a whole bunch of stuff here. So I'm going to do this. Now, typically to create a tool, um, let's say a tool to fetch a page, you use create tool. Of course, you start off with ID. ID is fetch page, right? Then you don't really need the name, but you could still have it, right? Um, Description would be fetches the raw text content of a URL for summarization. So let's say you want to fetch any URL, right? Okay. So that's then it allows you to do an input schema. So input schema. So we use this Zod's schema validation. For some of you, I think you already know Zod, but if you are not familiar with it, Zod is just a tool for you to validate data, right? And it's a very powerful and useful library. So the way you define it is think about it the same way you have nested, information. So you have Z dot object. So that means the input schema should be an object, right? Then inside that object, these are the things that should be inside that object, right? So the URL and URL should be a string. So you have Z dot string and it should be a URL type of string, even though that seems to be deprecated. Don't know if Z dot URL exists directly, right? And then describe. So this is to add a description when you're doing that validation. So the URL of the page to fetch. Okay. So that's URL. And I think that's the only thing we want to add. Okay. Um, yeah, so the name doesn't exist in the new implementation. Okay. So we have URL. Then we can also define an output schema, which is the result that is expected to come back. Again, it's an object, but in this object, you now have content, which you define content as a string, right? And then title, which you define as a string as well. And then we have word count, which you also define as a number. So this gives you the schema for the return value that you are expecting. Okay. So that's that. Then um, we have execute. So execute is a function that you execute. Now, because you have done an input schema, so take note, this input schema determines what comes in, and that URL is right there, right? That is what we expect. Then the right. So we have input data. So according to the ZOD, right, I would expect that we should have input data context, right? So we can destructure this and what I expect is a context. So context is correct. Now this context, um, let me just finish this. Then we'll fix the bugs later. Okay, so URL which we extract from the context. URL. It does look like URL is what we should have here. And then let's continue. So the results you will get is to fetch. So we are basically writing a tool that will allow us to access the access the internet, okay, and um pull information, right? So um because the LLM itself is not able to do that. So we'll execute the tool call from here. So headers, we can have a user agent, which is one of the types of headers that you will send. A lot of websites may bounce your API call, or this is basically like a fetch call, right? If you do not specify a user agent, even though to be honest, this is not we've done fetch calls and it's not always a problem anyway. So yeah, we are calling our bot summarizer bot. Okay, so user agent is Mozilla 5.0 compatible and summarizer bot. Okay, so that's our user agent. Okay, now, but I'm still having problems here. Of course, we have to return a value. Okay, that's why this is having this. So we'll have to return a value. We've already specified the input schema should be URL coming in, which we have pulled in here. But the output schema should be an object that has content, title, and word count. Okay, right. So um, if if the response is not okay, we should actually throw an error. Now, remember, when we're building agents, we're saying that when you're throwing, it's always a good idea to pass the error back to the um, agent, to the LLM rather, that is reasoning, so that it can figure out what to do. So in this case, we pull together the message res.status. Okay. So we throw an error. If the result is not okay, we throw a new error. Failed to fetch, we pass in the URL, we pass in the status. Okay. So but if it succeeds, then this line will continue. So we'll pull the HTML from it, and we get the res.text. because this is not, we don't expect a JSON call. Okay. We expect a HTML response. So we just await res.text. Okay. And just for the sake of simplicity, that you can take this HTML and directly send it back, but it is not safe to avoid things like prompt injection, and even cross-site scripting attacks. So it's good for you to strip the HTML tags. So there can be more advanced ways to pass the HTML, right? But we can do that later on. But just for the sake of this demo, we don't need to try to do anything more than, okay, let's just strip stuff to avoid, um, yeah, so this is a regular expression that does that. Basically, this regular expression is going to look for script tags, um, script start, script end. It will match any string. It will replace it with empty string, basically take it off completely. It will look for style tags as well that contain the CSS styles. It will also replace it with nothing. Then any other tag, right? It will replace it with a space. And then any space that is longer than 2 characters would replace with a single space. And that's mainly because if you have a bunch of um, other tags pulled together, you have space that is very long, right? So replace that with a single space. So if you have multiple spaces, yes, that's what this does. It replaces it with a single space, and then it trims off everything. So this basically is very simple HTML. Now, the other things you could do is extract the title from the HTML. So remember, we've taken out the script tag first. Then we can extract the title, right? Which is a title tag from the head. Okay, and you basically can use some regular expression again. So this is basically string manipulation. So you take the title out from the HTML, you match it, and you take the match, which is the thing in parentheses, right? And you trim it, right? So if you have a title, you use that. But if you don't have a title, then you use the original URL as a title. Then for word count, to get the word count, you can take the entire text again, right? So remember, the HTML is we still kept the HTML, right? It's the HTML used to get the title, but the text we stripped off the script tag, the styles tag, and every other tag, basically, right? And both opening and closing tags, and that's what we use, for as a text. So um yeah, so that's uh that's that is the text. Then the text is we split the text into words and we just take the length of it, and that gives us the word count. Okay. Um all right. So that gives us a word count. So remember, if you go back to look at our um if you go back to look at our um Zord output schema, the content is there, the title is there, and the word count. So we have effectively gotten the 3 parts of that. The content being the text, the title being the title, and the word count. So the only other thing is just clean up. So one of the cleanup is in order not to overload the yeah, in order not to overload the LLM, we can slice our and truncate the text, you know, um, basically split it to stay 8,000 words. So essentially what this is doing is it takes the text, it splits it by word boundary, basically spaces, and then it truncates and takes only the first 8,000, right? And then it joins it back with spaces. So you now end up with this text being just 8,000 words long. So again, well, I don't know if to avoid overloading the context window. So then we return all of that. So the content will be the text, the truncated text, right? The title will be the title, and then the word count is the word count. So this is a simple implementation of a tool, right? So we can already test this tool because remember we created, when we were creating the summarizer agent, um, we did not specify two calls. But now, in order to implement this, we can go back to the summarizer agent that we have here. We can then import the tools that we have defined. So import, let's see. So we already have exported the fetch page tool. So that's what we pass in, import fetch page tool. Yeah. So we import the tool. Okay. So after importing the tool, um, yeah, after importing the tool, we add it here. So tools, right? This is always a list. So we add a fetch page tool. So Mastra now knows. Okay. Um, right. So this, I'm still having this issue, but oh, I'm sorry. I guess I shouldn't be passing a list. I should be passing a dictionary, basically an object that contains the tools, right? So this is the correct way to pass tools. I was passing a list. Okay, so we now have this. So we can still run, and I'm going to do a little bit of a change to this because so far I okay, well let me just pass this in, right? But at some point I'm going to start passing um and I want to see if we can use that tool call, right? So let me show you. Check Wikipedia for the meaning of John. Okay. So let's do this. My name is John. So this is going to force it to make that you know um fetch page. So it's going to do that. So let's see if it will make that tool call. Unfortunately, I don't have any way of monitoring it right now, but we just okay. All right. So I need to agents tools. So tools. It looks like I always have to remember to put the but that won't work with that. That's because I'm running Node.js. I'm running Node index directly. But okay, at the end of the day, I'm still going to get the text stream. Okay, that's what I'm getting. That's what I'm writing. But one thing, um, yeah. So it actually did. You can see that it actually did an API call, and it actually did an API call. Let's see if it did my tool call. If it did my tool call, I guess a very easy way would be to log it here and say console log tool call and you know a fetch page tool called. So so now I've just manually logged it in. So I expect to see that right. So you can see it's called the tool call fetch page tool call. So this is proof that it actually used my Wikipedia um my fetch page API call to call for it, right? And interestingly, maybe I should have also logged which URL it came up with, which is interesting because I didn't tell it the URL it should use. Um, URL. Okay. All right. So yeah, so it's interesting that it was able to figure out this URL to use. Quite interesting. All right. But yeah, it did that and it fetched. Okay, so that's how you do tool calls. So we have a bunch of other tool calls which I will add to our summarizer agent. So the first thing I'll do is, since I have implemented fetch page tool in here, I'll rename this one to fetch page, right? So that's a fetch page tool. Then I will also create another tool. I need another tool that will save the summary. So I'll create another tool and I'll just dump this one here. So again, create tool from Mastra core tool, Zod. We get promises path, create tool. We have the ID description, and then we use Zod's input schema, Zod's output schema. And then here we're already in this, so we don't need this. I think this also has been updated. So and that's so we've defined title URL summary in our input schema. Output schema is the response, which should be just the file path. So yeah, we take the title, we slugify it, we create a file name, we put a .md, and then we join it, we create a file path.join. Path is from the path module, workspace summaries. So yeah, we should have a folder called workspace summaries, and then we put in the file, make that file. Then we generate this content, the source, you specify the URL, and the summary is the summary. So this is the second tool. All right. So now let's go back to our agents. We've already had our summarizer agent, but we are going to do a bunch of additional stuff with this agent. So the first thing we are going to do is we will create memory, right? So yeah, so let's add memory. So to add memory with with Mastra, you create a memory object first, new memory. Now, okay, so right. So of course we have to first of all bring in the memory class. So to get the memory class, you import memory from Mastra core. Um, so I'm depending on memory, right? So we import memory from there. Then um so we have different types of memory that I think we can get from here. We have a mock memory. Let me see if we have SQL memory. Working memory, shared memory. Right. So I think we're having a bunch of different things here. Oh, okay. So the errors was from me. So memory is no more in core. It's no more in master core. We have separate memory separated out. So um, yeah, we'll do master slash memory. And I have to install that. So okay. So right. So we get memory it comes in, and so we just create memory and we specify the storage. So the storage, we can use a new, this is just example. There are many different kinds of storage produced. The SQL store, right? Um, this allows us to to do the storage locally, maybe using an SQLite database. So of course we have to import that. Um, so import the SQL store from still from Mastra lib SQL libsql. Right. So we have to install that as well. Deep SQL. All right, so that's now installed. Okay. So we use lib SQL store and we specify the URL, in other words, where we want to where the database file will be stored. It's normally locally, or we can just store it and this is a way to specify it, right? Okay. This is a way to specify the URL, and the URL um specify a local file, but you use a file resource descriptor. Okay. So when you have memory, you have to specify the storage, and then you also have to specify other options. Options, there are a lot of options. So last message is one of the options which tells you how many messages should be kept in context, right? That's to keep in the context window. So because when you're using a database as your memory, you can have infinite storage. And the amount of storage can always exceed the context window of the LLM. So you have to be careful. And that's why you specify how much, right? Now, if you have a vector store, you can enable, um, so this is, it's really useful if the storage is a vector store, right? So set this to true if using a vector store. So if your storage is a vector store, then you set this to true. So that basically makes your memory a more semantic memory. So you can see how much easier it is. You can basically um, create a RAG that is smart, right? By using Mastra. Apologies for the we lost a bit of it was a network interruption, so apologies for that. Right. So I was going through memory, right? So yeah, so as you are doing memory, one thing you need to remember is um your memory can last much longer than your context window. So you have to be careful, right? To make sure that you truncate, or you specify the number of messages. So this depends on the size of your context window. All right, so we have memory, leave SQL. So we have to have an ID as well as a URL. Okay, so that's how you create your memory. Then after creating the memory, um, then the agent, we had already created this agent and we had already given it tools. By the way, I have added two tools. So we have this fetch page tool, we have another tool, save summary tool from, right. So we have that. So we can add this as well. And then we now add the memory. So we tell yeah, this memory is this memory. So of course, that's basically saying this is the memory you should use. So you can see how easy it is to integrate memory using Mastra, right? Then I'm going to improve on the instructions a little bit. I'm not going to type this all out, but yeah. So we have this, right? Yeah. You are an expert summarizer. Produce concise, structured summaries. Your summarize when web content clearly and concisely. When the user provides a URL, use the fetch page tool to retrieve the content, summarize using bullet points, highlighting key insights, keep the summary under 150 words. So remember the last time we did it, we brought in a bit of markup and stuff like that. But now you can tell it how to summarize. After summarizing, use the save summary tool to persist it. Tell the user where the file was saved. Rules: avoid fluff and filler phrases. Lead with most important insight. If the page cannot be fetched, explain why clearly. So you see that here we are now leveraging the power of the AI, which is the summarizing part. But other things, we give it tools and tool calls. And you can see how much easier it is to use Mastra to add memory, to use Mastra to add tool calls and all of that. So our agent is ready. We just um, updated it. Now, there's an interesting thing with Mastra. You can create additional agents, right, to critique the summary, for example. So this is where we'll use the whole workflow thing. So I'm going to essentially create um, yeah, so let's create another agent, right? So we've created a summarizer agent. Let's create another agent to call it critique. So yeah, so this agent is the agent we want to use to basically double check what our summarizer agent does. Okay. And again, we import agent from this, we create a new agent, IDs critic, summary critic. So this is its own instruction. It's a strict editorial critic. You receive a summary and evaluate it on accuracy. Does it reflect the source content faithfully? Conciseness, clarity. Respond with JSON in this exact format, you know. Yeah, so that's that. Um, Okay, so we have now made two agents. Okay, now we will create a workflow that will handle the summarization, right? So remember, you have agents, but you now want to kind of orchestrate those agents. So use workflow to orchestrate those agents. So we will create a new folder called workflows, and in that folder, we will put our workflow. Okay, so let's create a folder, call it workflows. Okay, then we will create a new workflow. We'll call it summarize workflow. Okay, then we will now set up the workflow. Now, this workflow has a bunch of things. The first thing I think we will want to pay attention to is the fact that a workflow can be made up of steps, just like chains. Okay. So we'll first of all import create workflow and create steps from the workflows submodule. We'll say use Zod for our validation. We'll pull in the tools which we are going to add. Then, so the first step one is to fetch the page, right? So the first step in the workflow is fetch the page. So to do this, we'll create a step, right? You could have said, okay, um let's just go ahead and you know let's just go ahead and just call the agent directly, right? But instead, in Mastra, you build things around workflows. Workflow allows you to kind of automate it, right? So we will create a workflow called the fetch step, a step first in the workflow. Workflows are made up of steps. So create a step and we call that step the fetch page step. Okay, that's the ID. Then we'll specify the input schema, just like every other thing. We use Zod. So the input schema, it should just be the URL, right, that we want to fetch. Okay. Okay. That's the first. Then you now have the output schema, which is also we'll declare the Zod schema for it. Okay. And we have the content like we've done before, which is a string, and then the title, which is another string, and then we will have the word count, which is a number, and then we'll have the URL, which is also a string. So this time around, we add a URL. So yes, so we've defined for this step. So this is similar to what we did before when we were running it. If you look at this, right, when we were defining the agents, right, hold on, tools, yeah, when we're defining the tools, rather, we basically did the input schema. So this same schema is what we'll use. As a matter of fact, we could have maybe stored this dot schema and reused it. But so you see that the schema we're defining matches a schema for the tool call itself, right? Okay. So after defining the output schema, we also need to pass in the execute, which is basically the callback, right? That will basically execute your, and it needs to match this. 。 right? That will basically implement that step. So it's the same thing, right? Since you are passing the URL, you will basically call the you call the agent fetch page tool dot execute, okay? And you pass in the parameters starting with the inputs, which is the URL, which is input data. Remember, it is a tool, okay? And yeah, so that's just passing in that, okay? Then you also will have uh request context, which is the context that you want to pass in if there is any, right? But right now there is no context, okay? So that's it. That's executing your tool call. Okay, so there's a whole bunch of TypeScript validation here, but um, I let me complete. So after running the tool call, executing the tool call, you get a result. So we will now return um, the result, and the result is going to is coming from the tool call, right? And it basically will have the same shape because remember that when we defined the tool call, the result had this content title and word count, right? That this comes from the tool call, and that's what you get in result: content title, word count. But the only thing is that using using URL is the additional one which we have to extend this to include. So I'm still going to come back to look at this. It seems I'm missing something here. Um, so it's easy to see this and see what the requirements are. Um, it is execution function, an execution function, state, step input. So you have execution function params, state, step input, and oh, that's going in a lot. So let's see. Typically execute should match what we define in here. Um, okay. I think I know what I missed. Yeah. So The params is what I missed. So I am not getting um the execute input schema, state schema. Okay, so the first one is state schema. Second one is input schema. Right. Okay, so maybe we should actually take input schema. Input data rather. Yeah. Okay. Input data. So this is what we should have. Input data. So URL is input data.url. Okay. URL is input data.url. Okay. Um, it says this is probably undefined. Well, I don't know. Yeah. We'll come back to troubleshoot this anyway. I'll leave this at this. Okay, so this gives us the first step, right? And then we have a bunch of other steps to follow. So I'm just going to so the first step is to fetch the page, right? Then um you can then make this second step to be the agent itself, right? The agent call, okay, and summarize step equals create step. So it's interesting that you can actually use an agent. You can use an agent to create a step. So of course, what this means is that that agent will be executed directly. It's interesting that, well, we could have just done the same thing here. But then we needed to bring in some input. So we had to kind of write this out in full. Now we create a new step by basically using the agent call. So this agent will be called directly as the second step. Then we will do a third step, which is to critique. So critique the summary that comes from this. So basically import the critique agent, and then we will create a critique step. Okay. So to create a critique step, we will But let me take this. Um, critique step. So we create step again. So you can see that workflow is basically about creating steps. So we'll give it an ID again. Then we define the input schema again, Zod object, and what we have is a text, which is a string. And then we have a title, which is also a string. And then we have the URL, which is also a string. So basically, we are getting text, title, URL. Those are the inputs that will come into the critique. Then we define the output schema as well. And it's again a Zod object that is made up of score, which is a Zod number. So basically this matches um the outputs, data, basically the output schema that we had made for the for each tool call, rather for the summarized tool call and for the previous steps. So this is an array, Zod array of Zod strings, then suggestion, which is what this critique would suggest in terms of, okay, this is how we can improve, right? Again, that is a Zod string. Okay, so we've defined our output schema now. So the next thing to define is the execute function, which is, so you can see that everything is tied to execute, basically, right? And based on this input schema, we'll have input data, then we'll have Mastra, right? That's what comes into this. Yeah, we'll have input data, we'll have Mastra. So Mastra is the Mastra server, basically. Okay, so you get the critique by getting the agent. So remember, this is a Mastra server or Mastra, should say Mastra helper, right? Get agent, right? Critique. So of course, we are using the ID that was assigned to this agent. So remember, when the agent was created, if you go to this here, you'll see that we assigned it this ID of critique. So that's what we are using. Okay, so we get the agent whose name is critique. And the beauty of this is if we put all of them in the same workspace, it's easy to just use Mastra to pull all of this using the IDs. So that's the orchestration. That's the scoping as well, right? Um, okay, so um, now the next thing is response. Await critique. So we are now using generate, and generate is basically going to run the query, right, that you specify here. So we specify that it should critique the summary of title, which we get from the input data, which is the summary that came, and then this is the prompt, basically. So you are saying, look at this title and text that was given to me and critique it, right? Critique it. So that's the response from the critic. So since the critic was uh, instructed to return JSON, we can then parse the JSON. So we try to parse the JSON. And if you remember the instruction we gave the critic, this is the format of the JSON that we asked it to give, right? Response in this exact format: score, issues, and suggestions, right? So it's actually going to hopefully do that. If it doesn't do that, then of course we will catch the error and then we can do something, right? In this case, we return a score of 5, meaning, okay, it wasn't a really good score. All right, then could not pass critique. So this is just an example. And then we can also add suggestion, right? But yeah, suggestion. So this output should definitely match the schema that we specified in load for the output. All right, so that looks good. We have basically completed the critique step. So now we have the last step, right? Which I'm just going to bring this in because we have kind of run out of time. And then I'll explain it. So you have the save if the score is greater than or equal to 7. So you have a conditional save state. This is just to show us how you can do conditional stuff. Input schema is the score summary title URL. Output schema is whether it was saved in the file path. So the execute part is to check if the input score is less than 7, then you log that and return save is false, but you don't save it. But if the yeah, if the input score is more than 7 or equal to 7, then you execute the summary, the save summary tool, and you specify the parameters, right? Title input data title, URL is input data URL, and so on, right? And then request context as any. So I'm still getting this the same thing I had here, but maybe we'll figure that out. Then you return this is true. Again, this is just maybe some kind of strict TypeScript issue. All right. Um, so now we have made steps. Okay. So the final thing is to build the entire workflow. And this is how you build the workflow. So I'm going to run through it again. So again, you just use the create workflow, as you can see here. And then you specify the ID, summarize workflow, input schema, is the URL, right? Right. And then the output schema saved Boolean file path. So we're seeing a lot of schema repetitions here, but that's okay. Then so you create the workflow and then use it then to add steps. So then fetch step, that's the step. Then you map the fetch step output, right? So the map will force the output from the fetch step, which is the input data. Remember, fetch step is giving you, you can go to the output schema for fetch step to show you how the output will look like: content, title, word count, URL. Okay. So in the map, you take that input, the input data into the map is the output data from the fetch step. So that will be input data. So summarize the following article: title, input data title, uh, input data the content. So that's the first thing. You take the title and content, which comes from the fetch step, title and content, and you map it into the prompt. Then you pass it on to the next step, which is summarize step, right? Map the summarize step text output into critique step. So the summarize step gives you an output, which you can go check it out again. Is the summarize agent. So it's basically going to match the output from the summarizer agent, which um, the summarizer agent basically gives you, it's basically going to give you a string, right? It's an agent call. It's going to give you a string, right? So that string is what you will now take and you map it here. So input data, right? Which is the input from the previous one, text title URL, and then get previous step output. And then you take that, the previous output from this particular um, step, which has the ID fetch page, right? That's this one. So you're going to take the previous input and you fetch, um, basically you call that previous step basically, and then you return the input data text, the title, and the URL. And that is what will be passed into the critique step, where the text is the actual text, then the title, and then the URL. And you just chain it that way. Okay. Then at the end of the day, you now do the conditional save step, which will check. And then commit will will store the workflow. So what we've done is we've created the workflow, we've stored it, right? But we haven't really implemented it. There are additional other things you can do, right? The workflow, you have branching, parallel, until, and so on. Okay. All right. Then, well, we can also look at RAG. So let me just quickly run through other things you can do because it's a lot. If we wanted to do RAG, right? Okay, so I have to install also npm install. I have to also install AI SDK um for OpenAI. In this case, I want to use Hugging Face. All right. So this allows us to call that. So okay, right. So this allows us to use for embedding. Um So interestingly, there's also some implementation that allows you, you can basically create a vector store from libSQL. So Mastra gives you that capability essentially. Remember we used libSQL, but it wasn't the vector version when we were creating agents, right? And we needed to give it some memory. We created memory with SQL store, right? So that's a regular store, but here we libSQL vector allows it to be a vector store, which allows semantic search and all of that. So to ingest plain text document to the vector store, okay, you will you have the M document first, right? Uh, M document allows you to do stuff like from text. You create a document from text, right? And then you can then do chunking and you can specify whatever strategy you want to use. So Mastra embeds a whole bunch of different strategies, right? With LangChain, you would have to pull in the classes and all of that. But Mastra kind of just wraps all of this for you. So you specify, for example, if you use recursive, you are probably going to do a recursive text splitter and so on. Then um, you can specify other function, other parameters, the size and the overlap. So when you do that, then the next thing is to call the embed function, right? And pass in the chunks. It will do an embedding. You specify your embedding provider. In this case, I did Hugging Face, so I'm going to use Hugging Face, right? And then we'll specify um, so I would use sentence transformer. Typically, you would use sentence. Well, Hugging Face embedding will always be sentence transformer. So we'll probably say all mini uh dash LM. I need to go check this name. I didn't actually memorize it. Okay, so that gives you your embedding. And then you can store it in any vector database. So you use vector store.offset. You create an index. If this index doesn't exist, it will be created. If it exists already, it will be reused. Okay. And then you specify the vectors that you want to offset. So this uses offset following Pinecone's, approach, which is pretty cool. And then you can add the metadata as well, right? So you pull the chunks and then you can pull the metadata, the text is c.text and then you spread it. So this allows you to add metadata. And that's all. So this is how you ingest. This is the ingestion part where you can ingest a document into a vector store. And remember, your vector store is part of the workspace. So you can access this vector store anywhere, anytime you like. So Mastra really helps you manage a lot of these things. Okay, so that's how simple it is to do ingestion. Now, the next thing you would do is you can now add a query tool. So you can add a tool to query this RAG, like I said earlier. So to do that, let's create a simple RAG query, a RAG query tool. Okay. So this RAG query tool, you build it like any other tool. Okay. Um, so you basically now so they have a helper function. So you don't really need to do a lot of work, right? You don't need to do a lot of work in order to do this, right? The first thing you need to just do is bring in the RAG, the create vector query tool from Mastra RAG. We still use this. We still use our Hugging Face, right? Okay. And we still use this vector database. So this can be an environment variable, right? So that you can shade across. If you go to our rack where we ingested, you see that we still the same database we use. So that can be an environment variable. Then we now basically use create vector query tool to create our rack query tool. Okay. And that's it, right? You specify the vector store name, specify the index name that you use, and then the model embedding. In this case, I use Hugging Face and embedding model, right? And yeah, we can specify the name of the model here. Description, search. So since it's a tool, you have to have a description, right? So for us to now use this tool, we can add it to any of our agents. Um, right? So maybe summarizer, or if we want to build another agent, we could actually build another agent. Or we can just add it to this summarizer agent and drag query tool. Okay. And that imports it for me automatically here. So yeah, so we have that. And the next thing is streaming, right? So if we want to stream, I think we've done that already. You can stream an agent's output. This is how you can stream an agent's output. Basically, we've done that anyway, so I don't need to. We already did that in index.ts where you can pull in the summarizer agent, right? Like we did. And then you can pass the summarizer is you pass in stream. You can then pass in the message, which is actually in this message format, which can either be a list of messages or anything else, right? And then if you want to enable the access to memory, so there's a bunch of other things you could do, right? So here I just did streaming. I didn't really specify, um, what else it could do, but let's assume that, yes, I've given it the message list, but I could also do other things. So let me show you all the other things you can give to it as additional options when you are streaming. You can specify thread ID so you can make allow you to have memory access call against multiple sessions. You can also specify resource ID. So if you want to link a thread to a user, and then you can also do other stuff when streaming is done, right? You can add additional stuff here. Um so this is how you stream a single agent call, right? The other thing you could do, you could also stream a workspace. So um let me add another, so let's just call it workspace.cs, right? Sorry, workflow. If I want to stream a workflow, index workflow. So this allows you to be able to stream a workflow. So streaming a workflow is almost the same thing as streaming an agent, basically, right? Um, you import the workflow. So in this case, let's import. Um, let's see if I can do this quick. Yeah, so we import the workflow. And then when you import, you just run stream, right? The run, you create a run from the workflow, basically summarize workflow.create run. Then you run it same way we were streaming, the index is the same way you call stream on it. When you call stream on it, then you can pass in a bunch of things, right? And um, it streams it, okay? And then you can run for await. Basically, you can loop the same way we looped here. You can loop across this and um, you loop across the events, and then you can either console log and all of that. So I'll run some of this for us to see. Well, I'm just kind of rushing because we don't have a lot of time. Um, so one thing we didn't really touch is eval. Okay. So what we'll do is I'm going to pause at this point. Next week we'll look at the rest of the stuff. We'll look at observability and eval, right? But um if we want to pull all of these things together, right? Let's go to server. I already had a server.ts I did before, but I basically bunched everything in here initially. So I had the workspace, and then we had the summarizer agent. I basically brought the agents here and all of that. But now, let's pull it all together. So we will import this. I need to also install the logger. Mastra has loggers as well. Um, okay. So we imported workspace, the file system, and sandbox, right? And then um, we imported the Mastra core, which is the server itself. We imported a logger. We now import the summarizer agent, the critic agent, and then the workflow. So I don't need to make the workflow here. And then I create a new workspace. Okay, so you can see very easily. This time around, I did not throw in basically just the file system and the sandbox. Okay, so this is basically the same thing that we had before. Now, I create a new master server. I pass in the workspace that has been created, and then I pass in the agents. Okay, so I have a summarizer agent, a critic agent. I could as well add the okay, I only have these two agents for now. Yeah, you can add any number of agents you want in here. They'll all be accessible. Then the workflows will add the summarized workflow, which we just did. That's the only workflow we've done. And then we add a logger as well. So we add all of this into the Mastra server and we maintain this. And then we can set up course if we want, so that we don't have a lot of issues with course, right? And that's it. We assemble all of this into a server. And once we run this server, um, basically that's it. We run the server and we'll be able to access all of those. So the interesting thing is that the Mastra generates endpoints for us to access each of these things, like we saw last time, right? We'll be able to access all of those by calling the API. So all the agents will be accessible through agent slash summarizer, agent slash critic, right? The workflows will be accessed through agent slash summarize workflow, which we already have. And so we can just run this and we'll see how this works. When we come back, we'll come and do eval, but let's just see how this works. So it's interesting how we pull all of this together and then we can have a master server. So again, I've not yet done the front end side, which is all in Node.js. That actually took a lot of time last time, so that's why I didn't go into that. But I really just want to focus on Mastra. So now I can run this, right, by we can just run let's see, new server, new Mastra. So to now activate the Mastra server, we will use PNP. We can either use npx exec, sorry, npx Mastra dev, right? Which will run Mastra in dev mode. Okay, same thing we would have just done npm dev. Or we can use that. Oh, I started out with pnpm, so should be pnpm exec Mastra dev. Okay, npx Mastra dev. Okay, so PNPM exec doesn't know about it. So, okay, we'll continue with that. So we'll now have the master server running in dev mode. The port will be this port, which we specify port 3000. And yeah, and that's it. It only allows this single origin, but I think I can let me stop this and um let me make this origin open to all for now for the purpose of testing. Okay. And then we run it. Okay, so I need to install Mastra, which I had not installed. I'll have to wait for it to install. Complete lock compromised. Okay, so this is all because I did everything with package npm lock. So let me back out and do everything with npm. So first of all, I'm going to remove npm lock, and then I'm going to remove node modules and just let um, so why the lock is compromised is because it's simply because npm interfered with it. So I'm just going to remove the package lock as well. So npm is going to handle everything, all the requirements. So let me just be sure that we have everything. Mastra, lib, SQL, loggers, memory rag, server, Hugging Face, React. So I think we have everything we need. Okay, so are there any questions on this while NPM is taking its time to install? Any questions? We will also need Mastra, which should have installed as well. One of the reasons why I prefer PNPM is because PNPM is faster. NPM does take a lot of time. All right, so I'll end at this point. We'll continue next week. We'll conclude this session. Okay, well, okay, NPM is done installing. Let's run npx npm install Mastra. Okay, let's do npx Mastra dev. It's going to install Mastra as well, which is okay. Okay. Um, Right, so there is an error here. npm install Mastra. Oh, sorry, no, that's not correct. We just install Mastra without specifying the version. So we have dependency issues. Okay. Um, yeah, so Mastra did get installed. So npm Mastra um dev. Okay. So we have dependency issues. I'll solve this and we'll work on it from next week. So we'll continue this session next week and finish
Oh.
Mastra basically. Okay.
So say Mastra and Mastra slash SDK, they are two different dependencies.
Yes. The Mastra that you have here
Yes.
is the server.
Okay.
Yeah, but these ones are all helper libraries that help you to build stuff. Right.
Oh,
So
okay, okay.
yeah, but
All right.
these are all like sub modules or sub packages in the
Oh,
Mastra monorepo. But
oh,
this is supposed to be a server. So, but I think there's a version conflict here. So I'll resolve this and we'll continue next week.
okay, see.
Okay.
Thank you.
All right.